I'd like to then introduce, I think we now talked about something that you're actually going to run on your clusters maybe a couple of years in the future. Many of you know OpenStack, and but maybe not many of you actually use OpenStack in a production environment because of concerns for security, etc. Here to talk about how you can actually overcome that is Bruno Almeida from F-Secure, who's actually on a daily basis now running a OpenStack implementation. So please, Bruno.
Yeah. Is this on? Okay. Oh, yeah. So, hello, my name is Bruno Almeida. Thank you for staying, because apparently there was a flock going off. How cool was this Skype thing? Maybe next year we should do everything with Skype, just easier. It was quite okay. I liked it. So I work in F-Secure. F-Secure, for the ones who don't know, it's a Finnish company that's famous for their antivirus or anti-malware products. Recent, we have another products like United, which is a storage in the cloud solution. And I work in F-Secure Labs, which is we are in the core of all these products. So I work in a team called Labs Development, which is responsible for doing all the systems that process multiple files, samples. We call it samples. It can be either binary data or just URLs, and we collect all of this and we store them and we process them, and we create things like the engines running on the core of all the products. So my team I'm a manager on a team called Lab Dev, as I mentioned, and we work in a DevOps fashion way. So we do the end-to-end responsibility of coding to the data center. We do it all. And we started with OpenStack in 3 or 4 years. Actually, who knows about OpenStack? Who actually works with OpenStack? Okay, so you guys can sleep for 5 minutes or so, because I'm actually going to explain a bit what is OpenStack. So OpenStack is a collection of multiple projects, and it enables you to build a cloud, either for private use or public use, but you can build an infrastructure as a service. And it's a fairly recent project. It started in 2010. And in 4 years, it achieved quite a big status in this kind of IaaS solutions. There are others, of course, but the main contributors for OpenStack were Rackspace and NASA. Rackspace contributed with their object storage solution, and NASA with their computing solution. And nowadays, it's actually OpenStack is a consortium of multiple companies. There's more than 150 companies contributing to this project. And there's actually some public clouds that you might know that are enabled with OpenStack, like Rackspace, for instance, or HP Cloud, or UpCloud, or etc. So we started in 2012 with this, and when we first saw it, it seemed quite. It was already a collection of a lot of these projects, so it seemed quite big. There are more projects more components or sub projects than this ones, but these are the key ones. Why? Because they enable the 3 essential things in a IaaS. They enable the computing part, and the storage part, and the networking part. So Nova is maybe the most famous component of OpenStack, and it's responsible for the compute infrastructure. You can think about it as something that does what Amazon EC2 does. Cinder and Swift are the storage part, either if it's block storage or object storage. And you can think, if you are familiar with Amazon, something like S3 or EBS volumes. They are quite essential, actually, for the IaaS platform. Neutron is actually, this project was renamed like 3 times in 4 years. It started as Nova Network, so it started within the Nova project, and essentially it became so big that they had to separate it from the Nova project. So they call it Quantum. And recently they renamed it to Neutron because it was causing some conflicts in the industry with some patent and some trademarks and whatnot. Neutron is actually, it's super important and it's super agile in the way that you can plug in multiple of existing things like Open vSwitch, for instance, or you can connect directly to some Cisco routers. There's a bunch of plugins that you can play around with it. And Glance is the imaging service. It takes it basically you can allow you can have a software defined network. It takes care of all the network part, the components. So I will explain a bit later, but basically you can put all your switches allowing all in trunk mode, allowing all kinds of VLANs, and just manage the VLANs with Neutron, for instance. You can create a subnet within a VLAN just using an API, and that's basically one of the key concepts of it. Well, it's a bit more. It allows more combinations, but this is at least in our use case what we do. Glance is the imaging services, and this is basically where you store your template images that you then use to deploy in the cloud. And Keystone also a big component, which is the identity service, and it's a kind of a glue that all of them need to use because it's responsible for the authorization authentication of everything within the cloud. And you can also you can connect it to some Active Directory or Open LDAP or whatever you want actually, because they're all open source and they're all written in Python basically, and you can pretty much play with them. That's actually one of the things that it's really cool about OpenStack. For instance, about the storage part and Swift part, we were one of the first ones, as one of the first companies that started to play with GlusterFS in OpenStack and make some experimentation. So it's really an open project. So nowadays everybody talks about the cloud or cloud infrastructure or running in the cloud, and we imagine as a very nice thing that we have infinite resources and we can deploy whatever we want and never ends up. But in the reality, it's just servers. And it's very hard to explain. I mean, my team, it's responsible for end-to-end, like I said, from since coding to the infrastructure. So we actually manage the data center, or part of the data center. And it's very hard to explain when we say we created an infrastructure as a service, so we created a cloud infrastructure. And it's very hard for some higher management or in other companies and even in our company to understand that it's not infinite. Everything breaks, the cloud breaks, and it's a pain in the ass. Sorry for the language, but to go to the data center, we need to swap things, and so I'm not going to sugarcoating this. So let's go back a bunch of years. Let's start thinking about how this changed, because it's important to know a bit of our history, what we have in the past in the company, and how this thing evolved. And you can think that we used to have one single server that stored everything. In some startups, it's called the server in the 90s, because they only had money for one server, so a physical server, so they put everything on it. Think a small application like a website written in PHP with some MySQL database, the LAMP stack. So Linux server, Apache, and MySQL, all running in the same thing. Let's start with this. So what happens when you have a single server and you scale? You will buy another server, and you probably will buy that will run the same exact thing, and you will put hardware load balancing to it. And that's how you used to do it. But then later servers became a bit more cheap, so you started to actually separate the services in the server into multiple servers. So instead of having everything in one, you started to have maybe actually a database server. So your MySQL went to one server and your Apache went to another, and because you started to expand your horizons. So when virtualization came to play, it was a huge thing. If you are managing a data center, you clearly notice that your bills going down if you started to use virtualized servers. And it allowed you to play a bit more with this. So you started to have maybe more than one Apache server. Maybe you started to have a bunch of Apache servers and a bunch of MySQL servers in the same kind of hardware. And we all know this, okay? So what changed with the cloud? Well, let's basically, if you do this, what I just wrote, multiple servers virtualizing, one service per virtual server, and here multiple servers virtualized and in the cloud infrastructure. I just CloudWatch my application. What changed? Nothing, or maybe everything actually. So what changed from the cloud infrastructure perspective to a normal traditional virtualized perspective? Well, nothing. You can actually have also use a SAN as a storage, and you will have compute nodes to go. But having an infrastructure as a service like OpenStack or others will allow you a little bit more things. First, you stop saying that your physical server needs to, or actually your virtual server needs to have 99.99% uptime. It doesn't matter. You don't care if a virtual server or instance crash. You don't care about it. You care that your service is always on. But if one of the Apache servers goes down, who cares? Because there's more. And one server started to have exactly only one service. He has only one job to do. One of the things that changed a lot is that when we deploy to an infrastructure as a service, to a cloud, we don't really know in which physical server, or actually we do know, but we don't really care in which physical server my instance will run. And that was one of the challenges for us. I will approach this a bit later. But exactly what changed by calling this infrastructure as a service or calling this a cloud infrastructure is that OpenStack gave us a lot of things already as a service that the normal traditional VMware or Citrix didn't allow us. For instance, load balancing as a service. Instead of now me having to put a virtual server with an HA proxy or buying a hardware load balancing, I can just use an API call and create one. Or for instance, for storage, instead of storing my files into a SAN or to a normal NAS, I just use object storage, or I create a distributed volume. All of this can be done with an API call. These kind of servers are already built in within the cloud infrastructure, and this simplified a lot of things. So actually, although yes, it's still like virtualized servers running on top of physical servers, there's all these services that come built in that allow a lot more. But not everything is made for cloud. If you are running in a company like F-Secure that has 25 years of history, there is legacy, friends. So you will not run everything on a cloud. The things that you should move to the cloud are stateless services. For instance, the Apache web servers. But moving a MySQL database to the cloud, you don't get much benefits from it. Replication is not really easy, and well.
When you say cloud, you mean your private cloud?
Yes, my private cloud. I'm talking about private cloud. Yes. So moving well, in this case, stateless service should be the only thing that you move either to private or public cloud. getting a bit back to this picture just to situate, we still have a lot of not just OpenStack, but we still have a lot of traditional virtualization using VMware, for instance. Okay, so we still have that, and in some cases, it's not really going away. This traditional VMs, but the cloud allows us to be more flexible. You can either scale vertically or horizontally according with your needs. Well, you can do this with traditional virtualization with VMware, but you cannot do it that easily as you will need to, at least vertically, you will always need to shut down the server and do a lot of things. And with the cloud infrastructure, we got auto-scaling groups, which there's already some business logic. You can build your business logic, but there's always a logic around the auto-scaling groups. If one of the web servers dies, it can just be replaced. A server is now a disposable element and not really a server, as it was in the 90s, for instance. Actually, it's really actually disappearing the concept of server in the cloud, if you think about it, because we started to calling it the server, then the virtual server, then in the cloud is actually called instances, and nowadays with technologies like Docker appearing, well, the LXC technology was already there, but with Docker coming into play, it's actually containers. So what you actually, you deploy your service in a bare minimum server. So when I joined F-Secure, and I come from a background as a system administrator, and I used to be also a software engineer before. So when I came to F-Secure, I came as a sysadmin, and one day my boss told me, build me a cloud. And I said, okay, what do I do? Because it it was not really like that, but okay. So I started to see about the technology that existed. And OpenStack was not that mature, but it was already a really strong candidate. It was quite flexible at the time, and still is. And there was also Eucalyptus and other ones. But I actually experimented all of them. In a week or so, I played with a lot of them. But I picked OpenStack in the end. And first, I started to deploy everything in one single server, just to try it out. So you can actually deploy all that OpenStack components that I mentioned before, everything in one server, and you will run a cloud. It's not a really nice cloud, but okay. It's a cloud. You can run things there. You have all the features, but of course you are bounded to the one physical server. So what's the next step? We started to deploy, still having only one single controller, we started to deploy just compute nodes. And the compute node is basically the Nova project that I mentioned. You are running that, and actually I didn't mention this before, but you can actually pick the hypervisor that you want with OpenStack. So we are running KVM, but you can run VMware, or you can run whatever you want, pretty much. So it's basically compute node. It's running the Nova project with KVM. So we started to deploy a bunch of them, and they connect to the controller, and all of these things are glued with. You need to use either a messaging queue system like RabbitMQ or Cupid, and you need to have a database like MySQL or Postgres, and it's kind of needed for using OpenStack.
Why you need the message queue? Why?
It's for the controller and and the compute nodes to communicate, to be aware of each other. And you also need to install the network agent in the nodes. But it's fairly simple to deploy a compute node after you have pretty much everything. So our next step after that is that we started to think about the storage part. So we, at the time, for this cloud, we only had, we were using just local disks. And it's not really nice to use local disks in a cloud, meaning that whenever you deploy something, and it ends up running on node number 1, So he actually copies that base image and starts running there. So if it dies, well, it's running on that local disk. If you have a problem with that disk, well, you cannot do really anything. So what we started when we approached the storage part was that we are already at the time using GlusterFS, which is a distributed file system, is like Ceph, or actually like Hadoop file system. There's people that use GlusterFS instead of Hadoop file system because we don't really have one single point of failure. But this talk is not about that. But we started to play around with that, and we actually were able to make live migrations because putting the machines running directly from the GlusterFS. And there you go. If the compute node dies, you don't really have some problems because they are running from that distributed file system. And we started only with one project, meaning we had one single tenant / project that had one single network, and we were quite happily with it. But then there comes the questions and the problems that all the managers like to do. So if I'm running my test workload on this cloud and my production workload at the same time, it doesn't really make sense that they run in the top of the same hardware. Like, what if there's some interference between my test network and my production network? I mean, they are running there. And OpenStack comes already with a lot of good things that you can do to mitigate this. Well, first it's common sense, you can deploy one project per, or tenants and projects are the same thing in OpenStack for a different use case. So you can have your development environment, you can as a project with its own firewall built in. It comes already with OpenStack, so you can have egress and ingress firewall rules. You have a virtual switching in OpenStack with Neutron and Open vSwitch, so you can create your own specific VLAN and your specific network just for that. And you can use the ability zones to play around with it. So you can deploy, if you want, your tenant in one region and your test tenant in one region and your production tenant in another region. But even without using the ability zones, it's actually quite okay, and it's quite isolated to run everything on top of the same physical hardware. But F-Secure is an antivirus or anti-malware company, so there is one problem. We actually need to run malware in order to know what it does. And try to explain to your CEO that you want to run malware in the same physical server where you have your normal production loads. Or actually try to go to Amazon. I actually dare you to do that because we did. Go to Amazon or other cloud providers and say, hey, I want to run malware in your cloud. Can I? We can't. And of course we can't. And because there's a lot of possible threats. There are actually threats that we saw, like hypervisor exploits, meaning that you have one instance running in that physical server, and actually the malware, you execute the malware on purpose, and the malware can actually infect the physical host and go to another instance. Or you can actually just have the malware that it's stubborn and it says it can actually identify I'm running on a virtualized environment, or I'm running on a VM, so I will not do anything. And or you run a malware that actually spreads over the network. It's a very common scenario. So yes, we could actually address all of this in the same cloud, but we actually decided no, it doesn't make any sense. We will not be protecting our company and our customers if we start running this in the same infrastructure. So we actually create a separate infrastructure with physically separate, different servers. It's a different identity, meaning that there's different credentials to that cloud. There's different networks, there's different computing parts, storage parts, everything is different. And even for the avoiding the virtualization recognition, you can actually tune up KVM to avoid, and you can fake that you are a physical server instead of virtual server. But of course, this also creates challenges because we still had to, of course, be able to communicate between the clouds. We avoid a bit. We created a lot of fail safes. Let's put it like this. We actually have this. In this case, it's a quite unique OpenStack infrastructure because, well, a unique network infrastructure if you think about it, because we actually are not just protecting from the outside to the inside, but we're actually protecting more from the inside to the outside, because we need to create a lot of fail-safes to avoid that malware to infect other things. Because even so, they are still running the same data center, so there's always some possible problems. But one of the most common scenarios in my team is actually the fast testing scenarios. And I'm not sure if you guys have the need or already tried to do this, but try to create, execute, and terminate an instance thousands of times per hour in a cloud. It's really, really crappy. Why? Because there's a bunch of residual data that's left behind. I mean, as I mentioned, it needs always a OpenStack uses Rabbit and uses or Cupid and uses MySQL or Postgres. There's a lot of residual data that's left behind. You can use it, but the performance is really bad. And we, from the traditional virtualization point of view, already had actually nice things to do this. So we try to combine both approaches. We have something called C, which is stands for sandboxed execution environment, which is basically a livered KVM on steroids. It runs everything in memory, and it runs pretty well. So our approach was, let's try to deploy an instance in our cloud with a lot of memory, and let's use nested virtualization. So let's execute these machines inside it, contained in that instance, and then we can just, after a couple of days, we can actually trash everything and recreate from the scratch. There are problems with this. The problems that performance. Of course, visualization. It was already mentioned today. You lose some. There's performance degradation. Using nested, there's a lot more. But we saw, based on our experimentation, that if you run this C or this KVM on top of VMware, you actually have a decent performance. If you run on top of KVM on top of KVM, it's really, really bad. And actually, it's really hard to overcome this issue because most of the cloud infrastructures are with that we have are with KVM. Although, well, we tried VMware with and then KVM, and it worked quite okay. But we are still on this phase of trying to test what's better, and we still have our traditional physical servers running this, and it runs quite fine. So cloud it's not good for everything, and that's one of the lessons to retain from this journey of us with OpenStack. But this is all I had for you guys. So thanks.
Thank you very much, Bruno. It's definitely very interesting to hear about your real-life experiences with this technology. Any questions for Bruno? One question from Marco.
Hello. Bruno, I guess you could kind of open up how many malware samples we are handling per day or per hour, because that kind of opens up the amount of stuff that you guys are doing.
Are you sure? Because you're from my company. Is that classified? No, I'm kidding. No, we have...
Trick question.
It's a trick question. I'm not sure if he's testing me or something. No, we actually have billions of samples stored, and we use for binary data, we use, like I mentioned, Gluster, but we could have used Ceph, for instance, and we call it we built a reputation system around it. So we have billions of binary samples, and for the network reputation, we store everything in Cassandra, and we have several hundreds of thousands. Well, it's hard, but it's hard to give an estimation, but I can tell you that at least per day we get around 1 million samples easily.
Okay.
Sorry, that means just it's 1 million, but it doesn't mean that was 1 million of malware. We also actually have a large collection of clean files, because actually we are measuring reputation, and not everything is malware, of course. Actually, the big percentage of things that we get is actually clean samples, which of course we use to give a fast response, what is good or not, and to create ratings and categories based on that.
Good. Well, thank you again, Bruno.